is located in the first quadrant. In the first quadrant and in the fourth quadrant, no? Oh, no, exactly. Okay, it's pi over 3. So the answer of this is pi over 3. Pi over 3. It's pi over 3. And the first quadrant, pi over 3. And in the fourth quadrant, or in the fourth quadrant, yeah. In the fourth quadrant would be 5 pi over 3. Okay, 300. In degree, this is 60 degrees. It's 300. Because cosine is positive, ¿no? In the fourth quadrant also. Well, okay. Entonces plugging in where? Plugging in the radio. Well, I'm using either equation, but in my opinion, the easier equation is number 1, no? R is equal cosine pi over 3. Que soy because 1/2. No surprise. It's 1/2. Look, it's 1/2. Now, both radio is 1/2, and 1/2. Entonces 1 point P1, let me call P1, would be in polar 1/2, comma pi over 3. Remember polar, this is R and this is theta. And P2 is also 1/2. It's all because the same radio, but this is 5 pi over 3, 300 degrees. Just the P2. But this is in polar. And what about Cartesian? It's important. It's important in calculus. You go from polar, but come back to the Cartesian because I want to make sure the point. Entonces, remember the formula for the conversion. X is equal R cosine theta, and Y is equal R sine theta. It's the formula for the conversion. Entonces is, you know, in the first point, X is equal 1/2, que es el radio 1/2, cosine pi over 3. Cosine pi over 3 is 1/2, is a coincidence, and 1/2 times 1/2 is 1/4. And Y is 1/2, que es the radio, sine pi over 3. Sine pi over 3 is radical 3 over 2, entonces 1/2 times radical 3 over 2 is radical 3 over 4. So the point, this point in rectangular P1 is 1/4, comma, radical 3 over 4. This is X value and this is Y value. Do you follow me? Oh no, oh, confusing.
I'm following you, Professor.
Okay, super. Now, but the point 2 is similar, no? As X is equal 1/2, but this is cosine 5 pi over 3. But cosine 5 pi over 3, que es 300 degrees, is exactly the same. The answer is 1/4 again. But the Y no, because in the fourth quadrant, the sign is negative. So 1/2, and this is sine 5 pi over 3, and this is 1/2 times negative radical 3 over 2. No positive like this. And the answer is negative radical 3 over 4. So P2 is the point 1/4, comma, negative radical 3 over 4. Okay, this is rectangular P1, P2. And this is polar P1, P2. R, comma, theta, or X, comma, Y. Super cool? Or complicated?
Yes. No,
Yes.
Super. As always, guys, you verify, double checking using decimals, right? To see if we are wrong, we are right. This is the beauty of that part. Okay,
Professor, sir, are you recording the class?
I suppose que no. Yeah, I suppose que yes. I did that. Or I suppose que some student do it. Okay. Okay, now. Let's move on to decimals to see the verification of our answer. Do you see decimal now? I have
Yes.
issue with the audio. Was having issue. You hear me well? Some people say they have issue with the audio.
Yes, I can hear you now. It was my audio.
No audio. Wow. Now it's okay?
Yes.
Okay, super. Okay. Look at that. Look at that. Look at that. Example one. Example one. Do you see decimals?
Yes.
In decimal we have circle and cardioid. Circle and blue color. Cardioid green color. And the famous intersecting point. The problem is that decimals give me the point in decimal approximation, but 0.25 is obvious que es 1/4. And radical 3/4, well, you know, is 0.4333. It's a rational number. Super clear? Cardioid and
Yes, it's good.
subcardioid and circle. Two figure and polar. Okay, nice. Intersecting is 2 points that we are doing by hand, and we verify in decimals. Any question?
I have a question, Professor.
Uh-huh.
The points that we like when we were in like the whiteboard, we calculate to find the points. We need to plot those points on the decimals, or it does that for us.
I plot in decimal. Look here. Nuela, do you see decimal, huh?
Yes, I can see it, Professor.
Uh-huh.
But you plug
Now,
in like the points.
look at the black one. I flashing. Is 1/2, get the radio, cosine pi/3. Comma, 1/2 sine pi/3. I put it here intentionally. In the paper, no. In the paper, I replace cosine pi/3, radical 3/2, and finally the answer actually is 1/4, no? But in the second point, que es the purple color, cosine 1/2 cosine 5 pi/3, comma 1/2 sine 5 pi/3. So I plot in decimal, yeah. But I plot, this is the problem. I plot like a rectangular, x, y. So decimal do not accept the convention for the polar. See, decimal is nice a little bit, but not 100%. It show you the polar plane, nice. Accept any equation in polar. So no x and y anymore, no. It's now my independent variable is theta, and my dependent variable is r. So you write like that, and decimal understand very well. But in the point, no. In the point, you need to specification x, y. Okay?
Okay, understood. Thank you.
Yeah. This is the, you know, not always is happy 100%, but it's something, no? It's support. Okay, this is a good question. Let me go to the whiteboard now. Let's move on to the second example. So basically today we have two equations. And you are doing the graph of this equation that you somehow reinforcing the idea for the identification, what kind of the figure. Remember, we have a lot of beautiful figure. We have a rose, we have a heart. Example 2 is you have r equal cosine 3 theta and r equal sine 3 theta. Wow, what the hell is that? Equation 1 and equation 2. Do you remember the graph of this or no? You have multiple.
It's like a system, Professor.
Yeah, it's a system. Actually, well, no. Okay, what is the idea? The idea is do the graph of both equation to the graph. This is the first part, and the second part is find intersect point. And the point that both graphics share, right? Now my question was, what is this guy? What do you remember? What is the how it look like? What is the name? I don't remember. First name, last name. What is that? Remember, we have different figures. We have a circle. We have cardioid. We have limacon. We have limacon with inner loop. We have rows, and we have lemniscata. And we have more, but it's enough for this. So one clue, wow, okay, give me information is when you have inside the trigonometric function 3 times, 4 times, and remember that this is the number of petals of this. You remember that? So actually, the first equation is a rose that contain 3 petals. 3 petals. So this is the skill. Remember, so recognize, identify the equation and the figure that you expect. No, of course, after we see more clear. Entonces, it's a rose like that. My sketch is horrible because the petal is symmetric, it's the same. For example, so you evaluate a theta equals 0 degree, cosine 0 is 1. So this is this point. And so we travel in this direction. Okay. So now, what about the second? Is similar, no? Because it's sine. It's the sine. It's a little bit rose, but rotate 45 degrees. So a little bit, I don't know. Another flower like that, and like that. Wow. We have 2 flowers, okay? 2 roses. Entonces, the challenge is find the intersect. You got the idea so far? So this is not important to do by hand. By hand is crazy. You can use in decimal, of course, but this is the last moment to double check it. So far, it's okay. And forget about this, que look like horrible. But don't frustrate for this. And let's compute the intersecting point now. To find the intersecting point, the same idea is radio 1 equal radio 2. Radio 1 equal radio 2. In our specific example, cosine 3 theta is equal to sine 3 theta. I need to investigate this equation. So to investigate this equation, I propose you, remember the idea always is isolate the trigonometric function. But entonces in this case we have cosine and sine. Wow, what should I do? Well, you divide by cosine here. And the cosine divided by cosine is 1, and sine divided by cosine is tangent. I did that. Somehow I manipulate identities, and I get only one trigonometric function, que es tangent in that case. Y I know very well que tangent is equal 1 in pi over 4. In pi over 4, so tangent is positive as any trigonometric function in the first quadrant and in the fourth quadrant. Here is pi over 4. I know very well que tangent pi over 4 is 1. This is the idea. So one solution is 1, is pi over 4. Oh, no, the argument equal pi over 4. And another solution is in 5 pi over 4. 5 pi over 4 is here, this is the 180 degree, no? Because this is pi over 4, this is 3 pi over 4, okay, 135 degree, and this is 7 pi over 4. But no. This is -1 and this is negative. This is negative in the fourth quadrant and in the second quadrant. Only is positive in the first quadrant and in this third quadrant. Do you follow me so far?
Yes.
Excellent. Now. One more detail que I explained in your moment, no? In the trigonometric equation. When you have multiplicity, 3, you need to consider the 2k pi or k pi, depending the period of the trigonometric function that we analyze. Well, in this case, I know que 3 pi, let me separate in 2 pieces, is equal pi over 4 plus k pi. Remember, you call 2k pi or k pi. This is valid for sine and cosine, and this is valid for tangent. Because the period of sine and cosine is 2 pi, and the period of tangent is just pi. That is, you should analyze the multiple of pi. So this is 5 pi over 4 plus k pi. This is the reason. Professor, what is the reason that you put k pi in one equation and another equation no? The problem is that we have a coefficient here that no 1, it's 3. When this coefficient is 2, 3, 4, 5, the effect for this transformation is the horizontal compress. And I know that we have multiple solutions. To investigate this multiple solution, you put k pi or 2k pi, depending si es sine or cosine or si es tan. Do you understand the idea? It's important that you understand this idea. Si you understand, I continue. Si you don't understand, I repeat in another way.
Can you repeat it, Professor?
Yeah. Nuela, when you have equation like that, sine 2 theta equal 1/2. The solution of this equation is different to the solution of this. Sine theta equal 1/2. You experience here two solutions. Tu solution que es pi over 6. In the first quadrant, y in the second quadrant es 5 pi over 6. But in this case, no. In this case is 2 theta is equal pi over 6 plus 2k pi. Because what is the effect this coefficient? This sign is like that. This sign is like that. And when you have equal 1/2, we have multiple solutions. How many? I don't know. You put k pi. When you overcome 2 pi, stop. Because I want the answer always in between one revolution, que es 2 pi. Makes sense?
Yes, it does.
Excellent. This is the thing I try to explain. Okay, entonces now,
Professor, please don't delete it. Let me just take a picture.
No.
Okay. I took it, thank you.
Okay, entonces we finish. No, we don't. Now, my goal is theta. You divide by 3. So theta alone is pi over 12, because 3 times 4 is 12, plus k pi over 4, no? And here, exactly the same. 5 pi over 12 plus k pi. Entonces I split the paper in 2 parts. Because actually we have maybe some solution overlap. Sometimes happen, but I have no idea. I try. So the first solution is k equals 0. For k equals 0, it's obvious que theta is pi over 12. Pi over 12, guys, is 15 degrees, no? Because pi over 6 is 30, divided by 2 is 15 degrees. But it's okay. And k equal 1, theta is pi over 12 plus pi over 4, ¿no? Porque k es 1. Entonces LCD es 12, pi plus 3 pi, ¿no? Es 4 pi over 12, que es pi over 3. And finally, k equal to theta is equal pi over 12 plus 2 pi over 4. Entonces pi over 12 plus pi over 2. Entonces es LCD es 12, es pi plus 6 pi, es 7 pi over 12. K equal to is 7. Pi over 12, 3 pi over 4. Okay, I'm doing something wrong. Yeah, of course I am doing something wrong. I'm crazy. Look. This is mathematics. Mathematics, you change one stupid number and it screw up everything. Okay, look. You divide it by 3. No, divide it by 4. So this is 3. This guy is 3, no? Okay, it's pi over 3. You divide it by 3 here. Divided by 3, divided by 3, and divided by 3. Cancel out pi. Okay, and likewise here, divided by 3, no? Okay, now let's start. K equals 0. K equals 0 theta is equal pi over 12. It's obvious, right? And also here, is theta equal 5 pi over 12. Because K is 0. K1 is theta equal pi over 12 plus pi over 3. K is LCD is 12 is pi plus 4 pi. Is 5 pi over 12. Wow, look at that. K equal 1 is a coincidence. K equals 0. Of course, you take one time. So they are overlapping of the solution. And actually, you break it down, this original trigonometric equation in 2 equations. However, bueno, you take the repetition, repeated some solution, it's okay, no problem. K equal 2. K equal 2 is theta equal. Entonces I forgot to do here. K equal 1, que es 5 pi over 12 plus pi over 3. Okay. Entonces LCD es 12, 5 pi plus 4 pi es 9. Es 9 pi. 9 pi over 12. Okay, when you reduce the lowest term, divided by 3 is 3 pi over 4. Okay, I like this. Of course, I like this. Okay, it's exactly the same of this. You for sure I like this. K equal 2. K equal 2. K equal 2. K equal 2 is, in this equation, is pi over 12 plus 2 pi over 3. LCD is 12. Is pi plus 8 pi. Wow, 9 pi over 12. It's a coincidence. Look, not always happen, but in this example happen. Okay, the solution of the next K is equivalent to the solution for the previous and the other equation. But sometimes it happens, sometimes no. K equal 3. How do you know you stop? Well, when you overcome pi, because the period is pi, and pi is 9 pi over 12, no es pi, es less than pi, ¿no? Entonces you continue. Entonces el continuo theta equal pi over 12 plus 3 pi over 3, or pi, look, pi over 12 plus pi. That this is too much because the period is pi. Actually, we discover the intersection in between these rows, 3 points. What is the point? Let me summarize. The point are pi over 12, 5 pi over 12, okay, is the same of this, no? And 3 pi over 4. get the same of this. And that's it. 1, 2, and 3. Okay, now in order to plot the point, intersecting point, well, remember in polar, we need r comma theta. Okay, I have in my hand theta, que es this. And in rectangular, well, I have x comma y. And you know the formulas for the conversion polar to rectangular. Okay, let's do it. Let's do it one by one. For example, the first point is pi over 12 is, well, use substitution in either equation 1 or equation 2. I want to use an equation 1. In order to find the radio, so let me organize this. Add theta equal pi over 12. Okay, entonces es sustitución r es equal cosine pi over 12 times 3, because the coefficient c is 3. R is equal cosine 3 times theta. Well, this is cosine pi over 4. And cosine pi over 4 is radical 2 over 2. This is the radio. This is this guy, R. So in polar, my first point is P1 is radical 2 over 2, comma, pi over 12. Super. However, if you want to express it, this in rectangular, well, using the equation for the conversion, x equal r cosine theta and y equal r sine theta. Let's do it quickly. P1 expressed in x comma y. Remember, this is r and this is theta. Now I need x comma y. X is equal r is radical 2 over 2. Radical 2 over 2. Cosine pi over 12. Comma, radical 2 over 2, sine pi over 12. Well, entonces sine, cosine, pi over 12, I have no idea. I put in the calculator or put in decimals.
So, Professor, this is the way we need to plug in on decimals, right? Like,
Absolutely.
Okay.
Noela, you put it like that in decimal. Decimal is a fantastic calculator. You can do it in your own calculator by hand. In your own calculator you have in your hand, physical calculator, or in decimal, is another calculator. Good. This is my first point, but we have 3 points. We have add theta equal, what the next? The next is 5 pi over 12. 5 pi over 12. Okay, 5 pi over 12. It is theta. The radio would be cosine. You plug it in either equation, guys. 3 times 5 pi over 12. This is equivalent to say r is equal cosine. This is simplification a little bit. Divided by 3 is 5 cosine 5 pi over 4. Okay, again is radical 2 over 2. But in this case, it's negative, no? Let me see, it's negative. Yeah, because cosine in what is no, this yeah, it's negative. It's negative, you're right. It's negative, no? It's negative because 5 pi over 4 is located in the third quadrant, no? Yes, it's negative. It's negative. Entonces, en P2 is a famous point, negative radical 2 over 2, comma, 5 pi over 12. Oh, And P2 in Cartesian or rectangular is minus radical 2 over 2 cosine 5 pi over 12. I put in decimal like that, comma, negative radical 2 over 2 sine 5 pi over 12. Boom. And decimals compute by me this answer. And we finish. Oh, remember we have 3 points. Where's the last one? The last one is 3 pi over 4. So add theta equal 3 pi over 4. Okay, by the way, 3 pi over 4 lie in the second quadrant, no? Yeah, in the second quadrant. So el radio is equal cosine 3 times 3 pi over 4. Okay, in this case, no cancel, it's 9 pi over 4. It's cosine 9 pi over 4. Pero any multiple of 4, in this case, lie, 9 pi over 4 lie in the first quadrant. So 9 pi over 4 is equivalent to say cosine pi over 4. Okay? Because you divide by 9 divided by 4 is 2, is 8, remain the 1 is 1/4. Actually, 9 pi over 4 is 2 1/4. It's like a 2 revolution. 2 revolution, no. Is, let me see. Is 1 pi and 1/4 of this, no? 1 pi and 1/4. This is 2 revolution is 1, 2 1/4 more. Here, boom. It's pi over 4. And pi over 4 is positive, radical 2 over 2. The point 3 is radical 2 over 2, comma, 9 pi over 4. If you want to write 9 pi over 4, it's okay. Or equivalent to say 3 pi over 4, que es the second quadrant. And P3 in Cartesian is radical 2 over 2 cosine 3 pi over 4, que I suppose que this is negative, cosine in the second quadrant is negative, comma, radical 2 over 2 sine 3 pi over 4. Boom. Look like complicated, but no, it's not too complicated. In my opinion, the most weird part is the classical thing every student forgot. And when you take calculus 2, you don't remember anything about this part. And the teacher of the calculus 2 need to explain again trigonometric equations because it's complicated. And you need to remember that when the coefficient is greater than 1, 2, 3, 4, 5, you need to consider the multiplicity of the solution. 2k pi o k pi, depende si es tangent, sine o cosine. Entonces, actually, my problem is two rows, one rows que es cosine, another rows que es sine, and we have 3 famous intersecting points. Any questions so far? I want to show you on this one now. Okay? No?
I said, okay, Professor.
Okay. Okay, no. Here. Okay. Example 2, guys. Example 2 is this. Look at that. Boom. Do you see? Okay. Let me show you in detail. The red one is the cosine. The blue rose is the sine. It's similar 3 petal, but rotate a little bit. And this is the famous point. Okay, we found. You put in, of course, in decimals. And decimal mandatory x, y, guys. So one solution, que this is in the first quadrant. Let me show you. Boom, first quadrant. One solution, que is 5 over 12, is in the third quadrant, I guess so. Yeah. Negative. And the last solution is the second quadrant. Look at that. Any question? Wow, fantastic. I like that. And remember the rows, when the number inside is odd number, 3, 5, 7, is the rows have exactly the same petals of this number. When it's even, no, when it's even, it's complicated. Because when it's even, you have 2 is 4 petals. But no, too much. Too much. Too much, too much. Okay. Any question in the example 2? I bring intentionally this example to illustrate or recall a little bit how you solve the equation. Okay. Let's move on to Desmos. You have no question. Do you see clear the idea or no?
Yes, because on this one you just plug in the points, right, Professor?
Okay, okay, super. Let's move on to example 3. We are doing intersection between the different graph of the equation and polar coordinate. Example 3 is, let me show you. Okay, example 3 is do you see whiteboard, no?
Yes, Professor.
Sine theta, equation 1, and r equal sine 2 theta. Whoosh, what the hell? Okay, this is the same job. Do the graph of both and find the intersecting point. Now, identification. What is the first one? The first equation. What represents graphically in the rectangular coordinate in polar? Sorry. This is example 3. Yeah. In example 3, what is the idea in the first equation? This is like a multiplication table. Suppose you are in elementary school, 3rd degree multiplication. You need to remember, right? Repetition, remember. This is a circle. This is a circle, right? But this circle is located on the y-axis. Here. Remember, when it's cosine, it's here. When it's sine, it's on the y-axis. Here. Sweet. Okay. Again, happening the diameter is 1, and the center is located at the point 0.1/2. Okay, this is the first one. And the second is a rose, no? It's a rose or no? Remember, it's a rose when you have, it's a rose. How many petals we expect? How many petals? How many petals have this rose? And sign. 2 petals. 2 petals. What do you say? I don't hear. 2 petals, 3 petals. 2 petals. No, 4 petals. Okay, when the number inside
because
here.
it's even, right?
Exactly. It's even. So we have 1, 2, 3, and 4 petals. It's like a mnemonic device, no? Actually, my figure is completely wrong. It's something like that. Look, let me try. Boom, 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 and boom. 4 petals. Totally symmetric. I did a mess here. This is not wrong. And the point, okay, I'm looking for is this point and this point. And we have in the other petal, we have no intersecting. Do you understand the idea? The mnemonic device means you don't need to remember. You put in decimal and that's it. And you see a 4 petal. But okay, I explained the lecture when I explained the basic equation. Okay, when it's a rose, the coefficients inside the argument of the sine or cosine, si es even, is multiplied by 2 the amount of petal of the rose. When it's odd, no, it's the same. Got it, the idea?
Yes.
Okay, now in order to find the magic points, you are doing exactly the same as always. R1 equal R2. The radius is the same. Sine theta is equal sine 2 theta. Okay, now I need to do something. Okay, in this case I can see okay, we have double angle formula. So you have double angle formula, I use 2 sine theta cosine theta. This is the identity of the double angle. Okay. Can you replace sine 2 theta by 2 sine theta cosine theta? Now, well, 2 sine theta cosine theta minus sine theta equal to 0. I move sine theta to the right hand side. You know, here interchange. Now factorization, the factorization is sine theta is a common factor. 2 cosine theta minus 1 equal to 0. And you apply the zero factor property. Exactly. In algebra, I do that. So sine theta is equal 0. And 2 cosine theta minus 1 equal to 0. Therefore, isolate cosine theta is equal 1/2, no? Because I move 1 to the right-hand side positive divided by 2, 1/2. End story. Okay, now the angle to satisfy this first part is theta equal 0 degree or radian, and theta equal pi radian or 180 degree. The theta to satisfy that part is pi over 3 in the first quadrant, and in the fourth quadrant, 5 pi over 3. So in degree, it is 0 degree, 180 degree. This is 60 degree, and this is 300 degree. Makes sense, right?
It does, but I can see better in degree than in radians.
Okay. That is the reason I put it in a different way. But little by little you associate. Because the teacher and the calculus always manipulate not in degree. The teacher in physics manipulate in degree because it's more visual. Physics is word problem. However, mathematicians know it's radian. And in calculus, definitely you set up your calculator in radians. Never we working in degree. Never. Because the operation that we are doing in calculus, when you set out your calculator in degree, do wrong answer. Okay? The calculus doing by radians, not by degree. But it's okay. They are equivalent in between that. Okay, I have that. Entonces now we have, bueno, we'll predict 2 points, ¿verdad? P1, P2, ¿no? Entonces, bueno, but I get 4 angle. Uy. Let me try to this 0 degree. Bueno, look. Is sine 0 degree is 0. Oh, no, I forgot. We have another point, is the origin. Look. We have another point, is the origin. In this case, look at theta equals 0. It's obvious that R is equal to sine 0. And sine 0 is 0. And the point is 0, 0. Pero R and theta in rectangular is the same. It's the origin, 0, 0. And theta equal 180 degree or pi. It's exactly the same. R is equal to sine pi. And sine pi is 0. So this point is for theta equals 0 and pi. Now the important point is this. This and this. This is in the first quadrant, que I suppose que es pi over 3. So this is P1. Let me go P1. P2 is at theta equal pi over 3. Entonces pi over 3, plugging in, in either equation, R is equal to sine pi over 3. And sine pi over 3 is 1/2, no? No, Oh, it's radical 3 over 2. Yeah. Hello. Radical 3 over 2. Therefore, the second point in polar is radical 3 over 2, comma pi over 3. Well, B2 in rectangular is, remember the formulas, x equal r cosine theta, y is equal r sine theta. I know in our specific point, r is radical 3 over 2, and theta is pi over 3. Entonces now is radical 3 over 2 cosine pi over 3, comma, radical 3 over 2 sine pi over 3. You want to leave it like that, no? You put in decimal understand very well. However, in this case, it's easy because cosine pi over 3 is 1/2. So actually, the point is radical 3 over 4, because this guy is 1/2, and this guy is radical 3 over 2. Entonces, radical 3 times radical 3 is 3 over 4. Bang. Nice. And P3 is P3. Add theta equal 5 pi over 3. Entonces R is equal sine 5 pi over 3. Entonces 5 pi over 3 lie en el fourth quadrant, and sine es negative. Es same value pero negative. Entonces negative radical 3 over 2, comma 5 pi over 3. However, professor, I see que P2 is here. I know. In the first quadrant, pero P3 is in the second quadrant. Entonces look like, no, the problem is que, look how you plot this point. This point you plot. You rotate 5 pi over 3, que es 300 degrees. Approximately, no, not here. Here, 300 degrees. Right? This is 5 pi over 3, 300 degrees. And now the radius negative, so it's flipped in the other direction. You see? And it's a lie in the second quadrant. Make sense or no?
It does.
Excellent. Be careful with the negative radius, it gets tricky. Okay, no problem. Entonces now I'm going to find P3 and rectangular. Well. It's minus radical 3 over 2 cosine 5 pi over 3, comma, negative radical 3 over 2 sine 5 pi over 3. Well. Entonces both are negative, no? Okay. Because in the fourth quadrant cosine is positive. Okay, entonces is positive. Entonces positive times negative is negative radical 3 over 4. It's the same value of this, pero negative. Because cosine in the fourth quadrant is positive, and sine no, sine is negative. Entonces 3 over 4. This is super clear now. Okay, this point lie in the second quadrant because the x is negative and the y is positive. We confirm this idea. Beautiful.
Yes, Professor, but I'm just wondering if you put in the calculator, it's going to give you like the same exact values.
Absolutely. Actually, look. I try to explain, no, to see a little bit by hand, a little bit with the calculator, but I put in decimal, and decimal is both. It's graphic calculator and compute anything. Anything you put in your lines, there is no graphic, you can find the value. See the order pair, you find both x and y and put together. Listen, any questions so far? Do you understand very well everything?
Yes.
Sure. Okay, no, I understand. Okay, let me see. Okay.
Professor, aren't you going to show us on Desmos how is?
Yeah, right now. I try to find one thing in my piece of paper first. Okay, 6, okay, super. Look, let's see this problem in Desmos. Okay, I did that. Example 3. Boom. Okay. Okay. Here, over there. Do you see this?
Yes.
Okay, look at that. Example 3. Look, Noela and company. I put equations. Sine theta. The only thing that you need to write in polar is r parenthesis theta, like f of x, equals sine theta. Boom. Yeah, I get the blue can represent the circle. Boom. Now I put in the second line sine 2 theta. I see to say immediately this monitor. Wow, it's a rose. How many petals? 4 petals. And you put the points. Okay, in this case we have only 2 points, no? Yeah, I put it schematically like that. Radical 3 over 2 because it's the radius cosine pi over 3, comma, radical 3 over 2 sine pi over 3. And the other point I discovered that the radius negative, negative radical 3 over 2 cosine 5 pi over 3, comma, negative radical 3 over 2 sine pi over 3. And we get the famous point in the first quadrant, in the second quadrant. Super clear?
Yes, and I can see it has like 4 petals, like you said, because it's even.
Exactly, exactly.
Okay.
See, for example, let me take advantage of this moment. Suppose you have 3 here. This is a completely different problem, no? Look. Oh, how many petals?
Now we have 3.
We have 3. 4 petals. What do you think? You put 4 here now. How many petals?
Now we have 7.
No, 8.
Okay.
1, 2, 3, 4, 4. And split symmetrically. Left and right. 4 on the right, 4 on the left. Yes or no?
Yes, the number is even. Yeah, you're right. If you put 6, it's gonna be 12.
6.
Right.
6. How many
12.
petals? 12.
Yeah. I got it. Thank you.
Okay, super, super, super. Now I skip number 4 because it's crazy. Number 4 and number 5 crazy. Look at number 4. Number 4 is, what the hell? Look at that. And number 5 is crazy. So I skip number 4 and number 5. Maybe extra credit for you. And number 6 is easy. Let me see. Number 6, I want to go to the whiteboard now. Do you see whiteboard?
Yes.
Okay. This is easy. Not complicated because it's R is equal 3 cosine theta. R is equal to minus cosine theta. Equation 1, equation 2. Identification, this equation, please help me to identify this equation. I am lost. I have no idea. I don't remember anything about polar. Okay.
The first thing that we need to do is do the graph and then find the intercepts.
Yeah. As always, step 1, do the graph. Step 2, find the intercept. The first graph, what do you think about the first graph? El circle es cardioide, es limacón, es rose.
Is a rose, Professor?
No. Rose is you have 3 cosine, 3 theta, or whatever. When you have coefficient here, no rose. That you need to make, so you have coefficient inside. This is rose. Chung. Right? When it's theta alone, no rose.
Okay, I see, Professor. Thank you.
Okay, this is the idea for this. The idea is to be a little bit more familiar with the graph and practice a little bit equation, trigonometric equation. Because it's the thing that we have in calculus. In calculus, the professor in calculus say, well, okay, you have two functions in polar. I need to find the area, or I need to find something. Suppose que it's a flower. So what is the idea in calculus? In the idea in calculus, you have You have the rows. Not exactly, but and you need to find the area for the one petal. Okay? Or you have, for example, a circle. And you have another figure, for example, cardioid. Then you need to find this area. To find the area, no, we don't know the tool for finding this calculus part. But you need to be ready in this moment to identify the figure that you are working and why not important the intersection point. Right? This is the idea. So you don't recognize the first equation, what it look like? What figure is this? Remember I sent the PowerPoint, no? To this. Pero no, I understand that you don't remember. Okay, pero I suppose que when the semester is over, you remember something, no? The problem is...
Limacon, Professor.
Say again.
I said that I think that is Limacon, like the graph.
No, no. It's a circle. It's a circle. Cosine and sine is a circle. Look, it's easy to remember. Cosine is a circle. What the hell? Cosine is a circle. Que the diameter lie in the x-axis. Si es sine, nuela, entonces diameter lie on the y-axis. Do you remember that? Sine, cosine, circle.
Okay. Professor, the PowerPoint that you sent, we had a shortcut, right?
Absolutely. Shortcut. It's immediately you see the function important. I see. No multiple, no. Si I see cosine for theta, it's a rows. Entonces, no rows. Es just one cosine. No constant. Entonces es obvio que es circle. Pero si es cosine, the diameter lie on the x-axis. And by the way, diameter is 3. So this distance is 3. I'm gonna print it. Okay, go ahead. But see, I have a PowerPoint. Do you want to put in the whiteboard the PowerPoint?
Yes, Professor, because it's easier to see.
Okay. Let me try to find. PDF. No, PowerPoint. PowerPoint. Pola. Power. It's a little bit slow, the PowerPoint. No, it's okay. Mira, circle, look at that. Nuela. I put a slider for the circle. Wow. Our first equation is cosine. It's this, the first one. Do you see? Do you see?
Yes, Professor.
And what about the second? The second I lost. I have no idea. Let me see. Let me go again to the PowerPoint. PowerPoint is... Well, in my opinion, look like Limacon. How do you know que es Limacon or cardioid or whatever? Mira, look, I call in the general AB, the coefficients AB. But in this case, minus. This is Limacon like that, like a second. Do you see second?
Yes. So we can mix two graphs in one, right, Professor?
Exactly.
Oh my God.
Oh, it's easy. Okay, now when you are doing the homework, you're supposed to do. Okay, entonces our graph, I don't know exactly, I don't know, I have no idea clear, but it will look like that. Like that. You know, el Limacon have a little bit curvy that part. And the point where we are looking for is that point and this point. P1, P2. Este intersecting. Super. After we see, I promise that we see super nice, super beautiful, and Desmos. Okay, let's move on to the trigonometric equation. Remember, R1 equal R2. This is the principle. That the radio and that point, both figures share the same radio. You copy 3 cosine theta is equal to minus cosine theta. Entonces, as always happen, I need to isolate the trigonometric function. Entonces, 3 cosine theta plus cosine theta is equal to, this is 4 cosine theta is equal to, divided by 4, cosine theta is equal to 1/2. Again, 1/2, the famous 1/2. Entonces, this is the pi over 3 theta in the first quadrant, and cosine is also positive in the fourth quadrant, get 5 pi over 3, so 300. This is 60 degrees, and this is 300 degrees. It makes sense, right? Look, first quadrant and fourth quadrant. It's supposed to be the radius positive. Compute the radio now. The radius R, you take either equation, because I suppose that R1 is equal to R2 and the point, I need to, so you select either, and the answer I suppose is the same. You trust to me, no? Radio is equal 3 times cosine pi over 3. Is cosine pi over 3 is 1/2. So 3/2. Okay, the P1 is the famous point 3/2, comma pi over 3. This is in polar format, R theta. And P2 is the same, 3/2, comma 5 pi over 3. R and theta. Now, if you want to plot in Desmos, though unfortunately we cannot plot in that way. Desmos don't understand this. Desmos understand this. 3/2 cosine pi over 3, comma 3/2 sine pi over 3, and 3/2 cosine 5 pi over 3, comma 3/2 sine 5 pi over 3. Okay. Entonces, in this case, well, this is easy value. Okay, we can compute by hand. Cosine pi over 3 is 1/2. And this is 3 over 4. Comma something. And the y value is radical 3 over 2. Entonces 3 radical 3 over 4. Okay, and the second is exactly the same because it's a 1/2 positive. 3 over 4. But this no. This is negative. Negative 3 radical 3 over 4. Clear? Wow, I like that.
Yes, Professor. Can you zoom it because I wanna take a picture,
Zoom it.
please? Okay, thank you, Professor.
Now in Desmos, and that's it for
Yeah.
today. Okay, wait a second. This is example 6. Oof. Look, example 6. Let me expand to see. I think I am doing. This is a circle, green. This is a lemacon. Lemacon without inner loop. How do you know whether it's in a loop or not? Depending on the coefficients A and B. When the coefficients is outside the trigonometric function is bigger, it's without inner loop. See, however, see I change this. For example, I put 3 here. Look at the effect. Bam. Do you see the inner loop?
Yes.
But no problem, no. I probably have only 1 here. I delete these 3. It's without inner loop. And the famous point are this and this. Look. 3/2 cosine pi over 3, comma 3/2 sine pi over 3. 3/2 cosine 5 pi over 3, comma 3/2 sine 5 pi over 3. End the story. Okay, guys, that is too much for one day. Too much, right?
Yes, Professor. Professor, I'm gonna be on your office hours tomorrow.
Absolutely.